Welcome to The Explainer. Today, we're diving into something that sounds simple but is a total game changer. A syntax that brings crystal clarity to really complex projects. We're talking about a way to make sure your requirements are written right the first time.
So let's start with a question, and this one's pretty high stakes. Imagine you're building a critical system. A single poorly written sentence that could have massive consequences. When you're dealing with complex engineering, a tiny misunderstanding can create huge problems.
Okay, look at this. On the left, that's the kind of vague language that just creates chaos in a project, right? It's where confusion and endless rework come from. But on the right, that's the kind of crystal clarity we're all aiming for. And the secret to getting from the left to the right, it's a surprisingly simple method called ears.
All right, so here's what we're going to cover. We'll start with why vagueness is so dangerous. Then we'll get into the solution itself. We'll break down the 5 simple patterns, see how it turns chaos into clarity, talk about putting it into practice, and finally take a look at where this is all headed with automation.
Okay, so first up, the big problem. Why does everyday language just fail when you're building complex systems? Well, using normal, unconstrained language for technical requirements is a recipe for disaster. It's just full of ambiguity and defects.
And we're not just talking about minor grammar mistakes here. These are serious, systemic flaws. You get ambiguity, you get incomplete requirements because you're missing triggers, you get logical inconsistencies, you even get defects that are just copied and pasted across the project. All of this just blows up your project's cost and schedule. It's a huge risk.
But what if there was a simple, elegant fix for all this? Well, there is. Let's talk about the EARS methodology. It stands for the easy approach to requirement syntax, and it's brilliant.
You know, ears wasn't just invented in some lab. It came out of a real-world problem at Rolls-Royce back in the early 2000s. A team there was wrestling with these incredibly complex jet engine regulations, and they noticed something. The clearest, most understandable requirements all seem to follow a very similar, consistent structure. So in 2009, Alistair Mavin and his team officially introduced ears, basically formalizing that pattern they discovered.
So, what EARS really is a type of controlled natural language, or CNL. All that means is it's a version of a normal language, like English, but with some rules on grammar and vocabulary. The whole point is to cut down on ambiguity and complexity. It's this perfect middle ground between rigid formal code and just, plain English.
So how does it actually work? Well, the real power of ears comes from 5 super simple, repeatable patterns. These are the building blocks of clarity.
And here they are. These 5 patterns cover almost every situation you'll run into. You've got ubiquitous for things that are always true, event-driven for when a specific trigger happens, state-driven for requirements that are only active while the system is in a certain condition. There's one for optional features, like if a certain feature is included, and finally one for unwanted behavior to handle errors. Each pattern uses a special keyword that defines the context.
All right, let's look at the first one, ubiquitous. This is for the basic fundamental rules of the system, the things that are always true.
The structure is just incredibly clean and direct. It's just, this system shall do this. No conditions, no loopholes. So, for example, the software shall be written in Python. See, that's a permanent, non-negotiable fact about the system. There's absolutely no room for misinterpretation there. Okay, next up is the event-driven pattern. This one is for when the system needs to react to a very specific single trigger. And the key here is that word when. When a trigger happens, the system shall respond. That word when is what signals it's a specific one-time event.
And this goes right back to that first example we saw. When the disconnect button is pressed, the software shall break the network connection. A super clear trigger leads to a super clear response. Perfect.
Okay, so when you start using these simple patterns, it has a massive impact on project quality. It really does take you from project chaos to clarity.
I mean, just look at the difference. With traditional requirements, everything is up for debate. They can be vague, inconsistent, hard to test. But with ears, things become clear and standardized. The risk of misunderstanding plummets, and, maybe most importantly, it lets the writer focus on the what, the semantics, instead of getting bogged down in how to say it.
And here's a really crucial point. By making sure a requirement has at most one trigger, EARS kind of forces each requirement to be atomic. That just means it's a single testable unit, and that makes verification way easier.
So EARS is powerful, But it isn't a silver bullet. You have to know the rules and limitations to really put it into practice effectively.
Yeah, there are a few key things to remember. First, keep it simple. If a requirement starts needing more than, say, 3 preconditions, it's probably too complex and needs to be broken down. Second, ears works great alongside visual models like state machines. And finally, challenge the pattern. If something doesn't fit, ask yourself, is this even a requirement? Maybe it's a goal or just some background info.
And finally, let's look at where this is going. Because modern tools are making ears even easier and more powerful, the future here is all about automation.
Yeah, we're moving beyond having to check this stuff manually. There are tools out there, like JAMA Connect Advisor or QV Scribe, that use natural language processing, NLP, to check your requirements against the ears patterns in real time. They can integrate right into the tools you're already using and suggest better, ears-compliant ways to write things. It's pretty amazing.
And this is really the bigger picture, right? By making our instructions so clear that a machine can actually understand them perfectly, we're setting the stage for the next generation of engineering, with AI assisting us. So it leaves you with a pretty big question. If we can teach machines to understand us perfectly, what are we going to build next?